Hello class, this is the third lecture for Math 172. We're going to look at converting angle measures between degrees and radians. And then the second part of this video we'll go back the other way, between radians and degrees. So the secret here is nothing fancy, is we're just going to use this over and over and over again, meaning this pi over 180 degrees. That's the what we call conversion rate to go from degrees to radians. Alright, so I know that pi radians and 180 degrees are equivalent. So multiplying a measure by this is akin to multiplying it by 1, because they're the same thing. But what happens is I end up with a multiple of pi when I end up with this measure. And it's okay to abbreviate RAD for radian. But 45 will go into 180 4 times, and we're left with 1 times pi is pi. And then there's nothing left. There's no denominator here, but down on the bottom here there's a 4. So we end up with pi over 4 radians. So 45 degrees is pi over 4 radians. And then the same thing here. I'm always going to multiply this by pi over 180 degrees, and I'll get the equivalent radian measure. Alright, so the zeros can cancel out, and then there are 2 6s and 12, there are 3 6s and 18, so I end up with 2 pi over 3 radians. Alright, 330, same thing, I'm going to multiply by pi over 180. Again, I'm going to reduce those. I end up with 11. 3 will go into 33 11 times, 3 will go into 18 6 times, and I end up with 11 pi over 6 radians. Alright, so those are some actually common, it seems weird right now that that's a common angle measure, but 45, 120, 330, these are multiples of things like our half of 45, multiples of 30, multiples of 60, very common angle measures in trigonometry, 30, 60, 90. You've probably heard of 30, 60, 90 right triangle. Very common things that we see in trig class. Now 100 degrees, as a common number that is in just our number system, it's actually not a very common number in trigonometry. But we convert the same way. We always just multiply by pi over 180. I always reduce the zeros first. And then these don't have like a common 3 or 6, but they do have, they're even, so I can reduce this to 5 and 9, so I end up with 5 pi over 9. Alright, and then 27 and a half, same thing, I multiply by pi over 180 degrees. And then I'm going to try to reduce this as much as I could. So if I'm going to use like a TI calculator, I'm going to ignore the pi. Put the 27 and a half over 180. Then I'm going to use this math, convert it to a fraction button. Alright, and there's 11 over 72. So I end up with 11 pi over 72. Now be careful when you're doing this, because sometimes in your homework it'll ask you to round these, especially if they have decimals in the degree measure, and it's fine to round those a lot of times. But there'll be many times where these, what we call the special angles, and the special angles are going to be multiples of 30 degrees, 45 degrees, right? So like 60 degrees is a special angle, 90 degrees is a special angle, 120 degrees. Basically, if you take these first three and you start doubling them and adding them together and things like that, you'll start getting what we call the special angles. And those are the ones that you're going to be expected to know how to come up with those. I skipped 135. But these are just multiples of the first three, basically, are what we call these special angles. And these special angles, especially, you're going to be expected to have exact versions of those radian measures. Alright, and even for some of them that aren't special, like 100 degrees, if you can reduce that fraction, and just like we did with this 11/72, you're expected to write those in multiples of pi as well. All right, now let's go back the other way. Now, what if I have something like convert 3 pi over 4 radians to degrees? All right, now we're going back the other way. So instead of multiplying by pi over 180, it's still equivalent if I wrote that as, instead of pi on top and 180 on the bottom, to put 180 on top. 180 degrees is also pi radians, so it's still multiplying by 1, but now the pi's are canceling away, and I'm going to end up with just degrees. All right, it's technically this is radians, and this is pi radians, so the radians are canceled, not just the pi's, but we're ending up in degree measure. Okay, so the pi's are gone. 4 will go into 180 45 times. All right, and then it's 45 times 3 is what's left over. So we end up with 135 degrees is the same thing as 3 pi over 4 radians. So when you want to go from degrees to radians, pi over 180, and if you want to go back the other way, like we just saw here, it's the 180 over pi. And that'll get you in the right format. Okay, it's whatever you want to get rid of is basically going down the denominator. I want to get rid of degrees. Degrees goes down the denominator. I want to get rid of radians. Pi, remember this is radians, goes down to the denominator. All right, so that's converting from one measurement of an angle to another type of equivalent measure in a different unit of measure, radians versus degrees.